Hello guys, this is Imanshu from Code Campaign and we are continuing with our binary tree module. So the problem that we are going to discuss today is mirror of the binary tree. So let's first see in which interview this problem is being asked. So this problem is being asked in Paytm, VMware, Microsoft, Ola, Snapdeal, Adobe, Myntra, eBay. So this problem is being asked in a lot of interviews. That's why we are solving this in this video. So what is the prerequisite video for this problem? The prerequisite video is the binary tree traversal, specifically the post order traversal. So if you haven't watched that video, please click on the right side of the screen, the pop-up which is being shown. It will take you to the video of the binary tree traversal. You can watch that video and then come back to this video to understand it better. Okay, so let's move. So what is the mirror image of the binary tree? So suppose we put this binary tree in front of a mirror. Okay, now let me change the pointer quickly. Okay, so cool. So if you put it into the in front of the mirror, what you will see in the mirror? So you will see this portion will come here. Oh, so this will be 2, and then this will be 4, this will be 5, this will be 6, right? And then this portion will be shown here, right? So this is the mirror image of this binary tree, right? So now this is what you have to do. You will be given the root of this particular binary tree, and you have to convert it into this binary tree. You have to return the root, which will convert the binary tree into this binary tree, the mirror image of the binary tree. So how do we identify that this binary tree, given this binary tree is being converted into the binary tree, which is mirror image? So basically what we'll do that in order traversal. So print the in order traversal of this binary tree. So what will be the in order traversal? It will be 4, it will be 2, then it will be 5, 6, 1, 3, 7, 8. And what will be the in order traversal of this mirror image binary tree? It will be 8, 7, 3, 1, 6, 5, 2, 4, right? So if you see this sequence is completely reverse of this sequence, right? So if I give you a binary tree and say convert it into the mirror image of binary tree, and if I print the in order traversal of both of the binary tree, they should be reverse of each other. Okay, so this is one part. But now the problem is how you will be able to convert this tree into this mirror tree. Okay, so if you look closely, uh, here, what we can do, actually what we are doing here, we are actually swapping the left child with the right child at each and every position, right? So if you see here as well, we swap the left child with the right child, and at this also this is null. So here also we swap the left child with the right child. So if we swap all the left child with the right child present in the tree, then you will be able to get the mirror of the given binary tree. Okay, that's fine. So but how we'll do it while writing the code? So you already familiar with the post order traversal. So let's do the post order traversal on this tree. Okay, so the post order traversal will be what? First we explore the left, and then we explore the right, and then we explore the node. So first explore the left, so we'll come here. Now the left is 0, so we'll go on the right. This is 0. Now when we reach and when we explore the node, what we had to do, rather than exploring the node, we have to swap the left child with the right child. So in this case it will be what? This null will go here, this null will come here. So nothing will change because they both are null. After this, what will happen? We'll go to 2. So we explored the left side, so we'll explore the right side of the 2. So we'll come here. Now we will go into the left side of 5, which is null. So we'll go into the right side of 5. So the right side of 5 is 6. So we'll go into the left side of 6, which is null. again the right side of 6 is also null. So we'll swap both of these as they both are null, so so we cannot see the change. Now we'll go back here for 5. The left and the right side both are explored. So now we reached at the node. So again what we will do, we'll swap the left with the right. So what will happen here? This 6, let me draw with the other color so it will be easy to spot. So this 6 will come here, right? And this part will become null because we swapped both of the part, right? And then we'll come back here at 2. Now for 2 also, right part and the left part, they both are being explored, right? Let me remove this. They both are being explored, so we need to again swap the left child and the right child. Okay, so for 2 what will happen? So suppose this is 2, so for 2 5 will come here because this is the right child, so we'll replace it with the left, and the left will come here, right? So if you see this is similar to this one now. Okay, now again we'll do the same thing here for 3. So if we do it for 3, so after 2 what we'll do, we'll come here. So for 1 left part is explored, so we'll explore the right part, so we'll come here for 3. For 3 we'll again go into the left part which is null, so we again go into the right part. So we'll for 7 we'll again go into the left part which is null, so we'll again come into the right part. For 8 we'll again go into the left part, then we'll go into the right part. They both are null, so we'll swap, but we'll not see the change because both are null, so nothing will happen. Now we'll come back to 7. So for 7 also we explore the left part and the right part, so we'll swap, right? So let me erase this one. Okay, and let me put 7 here. Let me put here what happened to 7. So 7 8 will come on the left position and null will come here, right? Then we'll go back to 3. So what will happen for 3? So again we'll swap, right? So for 3 what will happen, the structure will be like 7 will move here, and with 7 8 will also move, right? And the null will come here. Now we'll come to 1, right? So for 1 again we have to swap these two. So the right child, which is 3, will come on the left position, and the left child, which is 2, will come on the right position. So these are the two childs, right? These are the two. So this is right now on the right position here, and this is right now on the left position. So the final image of the tree, what it will look like. So this will come here and this will come here, right? So suppose 1 is here, so it will now point the left, and this will not point to the right. So this is how our final tree will look like, and which if you see closely, let me remove all this so this will be clear, right? So if you see closely, mirror image, right? Okay, so now I think you understood. We have to apply the post order traversal, and while at the position where we were printing the node, other than printing, we have to swap the left and the right node. So now let's go ahead and write the code for this traversal, or code for converting the binary tree into the mirror image of the binary tree. Okay, so this is our ID. So let's start writing the code which will convert our tree to mirror image of the binary tree. So mirror of binary tree. Again, same thing. If root is null, we'll return. And then what we have to do here, we have to write the post order traversal, right? So post order traversal, what we do, first we move to the left, then we move to the right. After exploring both left and right, what we had to do in this case, what we were doing here, we were swapping the left and the right children. So let's swap them. So let's take one variable which will hold our temporary node. So we storing our roots left in this, and then what we have to do, we have to make our root left as root of right. So what we are doing here, we are making left to point to the right. So actually now our left will be pointing to the right. Now what we do, then we'll say okay, yeah, now point our left, oh, point our right to the temp value. So first what we did, we stored our root left children into the temp variable. Then we modified our root left to point to the right. And then what we did, we said okay, now root right should point to the where the root left was previously pointing. That's why we needed a temp variable, because we are overriding here. So we cannot say now point to the root left, because at this position we change it to point to the root right. So we needed a temp variable to store the root left where it was previously pointing. So now after doing this, this is all we have to do to change uh, into the mirror of the binary tree. So now let's go ahead and print and see if whatever we wrote works or not. So first what we'll do to visualize it, we'll first print the in-order traversal. Okay, so let's see how the in-order traversal of this problem looks like. So our tree in-order traversal looks like this. That's fine. Now what we'll do, we will use oh, core utils mirror function to convert this tree into the mirror image of the tree. After this, what we'll do, we will just, here I'm adding the new line, so at least we will be able to see. Now again, we'll print the in order traversal. So now this in order traversal which we are printing right now should be the reverse of the in order traversal what we printed previously, because now our tree is being converted into the mirror image of the tree, right? So okay, now let's go ahead and check. Okay, so now let's compare. So 4 is being moved here, 2 is being moved here, 5 is being moved here, 6 is being moved here, 1 is moved here, 3, 7, 8. So that means this is the reverse. That means we are able to convert our binary tree into the mirror image of the binary tree. So let's go back to our code and do a simple code walkthrough. So at least you will be able to understand it better. So let me move to our presentation and let me. Okay, so we'll do a quick code walkthrough here. So as you see here, I have pasted the code, whatever we have written in the ID, and let's start from here. So we'll start from here. Let me change the pointer. Okay, so we'll start from here. So we'll get 1 as a root here. Then what we are doing here, we are moving towards left, right? So we'll come here. Then we are again, we'll pass 2 here, right? And then we'll again move towards left. Then we'll pass 4 here. Then we'll again move towards left. Now at this moment, we'll hit this if condition and this will be true. So we'll return. So we'll return. Then after returning, we will return from this function. We will go here. So our root at this moment was 4, right? So we'll move to the right of the 4. So the right of the 4 is again null, right? So we'll again come here and we'll hit this if condition and this is true. So we'll again return, right? So we will return from this portion. So we'll come here, right? And our root is at this moment 4, right? Our root is 4. So what we'll do here, we'll store the root left in temp. So root left is null. So we'll store null here. Then we'll go here, we'll say root left equal to root right. So then again, root left will become null because root right is null. Cool. Now what will happen? We'll say root right equal to temp. So root right, so temp was null. So root right will again become null. So that's all. So let's move this. Hmm. So we'll go out of function call. Our function call will end here. Then what will happen? This will be destroyed and will, because we made a call previously, making a call to 4, where we were at 2, so we completed the 4, so we'll move at 2. And from where we made this call, we made this call from the left, right? So we'll go on this. Now what this function says, move to the right of 2, right? And this is true. After completing the 4, we'll move to 2 and then we'll move to the right of the 2, right? So to the right of the 2, so what will be the thing? It will be 5. So we'll pass 5 here. It's not null. We'll come here again. This function is saying go to the left of 5. So the left of 5 is null. So we'll pass null here. This if condition will be true, we will return. So we'll return from here. We are returning from the left, so we'll go into the right. And this is saying go to the right of 5, right? Because at this moment where we are at 5. So this is showing, and this is saying go to the right of 5. So the right of 5 is 6. So we'll pass 6 and then we are at 6. So 6 is not null. We'll come here, is saying go to the left of 6. So the left of 6 is null. So we'll again pass null. This true, this condition will be true. It will return. So left part will return. So we'll go into the right part. Right part is again null, so this condition will be true, so we'll again return from the right part. Now again this temp will contain null because left is null, and then our left will be root right, so this is again null, so left will be null, right will be null, nothing will happen, right? So this will be same as what happened in the case of 4. Now we'll return from 6, so 6 will be removed, 6 function call end, and we'll go to 5. Right? So for 5, what happened? We are returning from the right side, so this function is also explored, so we'll reach here. Now here, see what will happen. Temp is equal to root ka left. So root is what? 5. So root left is null. 5 left is null, so this will be null. It's saying root left equal to root right. So root right is 6, so this will be 6. So left will become 6 now. Okay, and then root right equal to temp. So root right will be temp is null. So root right is temp. So now if you see here, what happened? Come on. Okay, so what happened here? This became null and this became 6, right? So we swapped it. Okay, so okay, after this, what will happen? 5 call will end. So 5 will be destroyed and we will again reach to 2, right? And call to 5, from where it went? It went from the right side. So we'll return from the right side. So after returning from the right side, what will happen? Again, the same equation will be applied, right? So let's apply once more so you will understand it better, right? So now temp will become what? Roots left. So roots left is what? 2's left is 4. So this will be 4. Then root left equal to root right. So root left is this, and we are saying root left become root right. So our left, root left will be 5. This complete thing, right? This complete thing. Hmm? So this will point to here, and again 6 is there, so even if I don't write 6, so that is understood that 6 will also be there. Now root right is equal to temp, so this will point to 4, right? So now what will happen in this case? If we draw 2 here, so 5 left now is pointing to 5, and which is pointing to 6, and this is pointing to 4, right? So if you see here, we swap both of these nodes. This thing is swapped, right? So what I want to do for you guys run this complete code for the later. So now the two part second will end, right? Will go at 1, right? And after this will fall from here to here, then we'll go into the right part of the 1, and then the same thing will happen here, and ultimately these two will also be swapped. So what I want you guys to do is to run through the half part of the code on your own, so you will understand it completely. If you are unable to understand, put your question into the comment and I will reply there. But I want you guys to go ahead seriously and run the recursion for the right part, so you will understand the complete thing better. So okay, so now code walk is done. So now let's move forward. So what will be the time and the space complexity? Again, so you guys already seeing here what we are doing a simple post order traversal, and for the post order traversal the time complexity is on and the space complexity is also on, right? It's pretty simple if you have watched my previous videos. So that's all for this video. If you haven't subscribed to my channel, please go ahead and subscribe to my channel to get the updates for the future video. If you really like the video, please go ahead and give it a thumbs up so that it will come up into the YouTube search and other people will also be able to see this video. And if you have any question, please put it into the comment box. I will reply. So that's all for this video. See you in the later video. Thank you.